All right, let's kick off this deep dive. We're going to explore a really cool NASA mission, and you know we love talking about cool NASA missions.
Definitely.
So we're diving into the world of space weather today, but hold on, we're not just talking about pretty auroras. We're
Right.
going deeper than that. We're going to see how space weather actually messes with our technology here on Earth.
It's a pretty big deal. Yeah.
It is. And get this, we're going to go behind the scenes of a mission that's being designed to actually predict those solar
That's
storms.
some next level stuff.
Oh, it is. And for all the details, we're turning to this awesome Space News article all about a mission called Tracers. Ready to get into it?
Let's do it.
All right. So Tracers, it stands for Tandem Reconnection and Cusp Electrodynamics Reconnaissance Satellites.
Wow. That's a mouthful.
I know, right? Doesn't exactly roll off the tongue, but gotta admit, it's a pretty cool name.
Yeah, it's pretty cool. And, it kind of gives you a little hint about what the mission is all about.
Okay, I'm intrigued. Tell me more.
So the main objective here is to understand how the solar wind interacts with the Earth's magnetosphere.
That's the magnetic field around Earth, right?
Exactly. And they're especially interested in a region called the polar cusp.
Ooh, the polar cusp. Now that sounds interesting. Why is that spot so important?
Well, that's where things get really wild
Hmm.
because that interaction between the solar wind and the magnetosphere at the polar cusp, that's what causes, everything. From the northern lights
Oh, wow.
to those geomagnetic storms that can really mess with our technology.
Yeah, those geomagnetic storms sound kind of scary.
They can be, yeah. And to really get a handle on what's going on there, Tracers is sending not just one, but two identical satellites up to space.
Wait, two satellites. Why two? Wouldn't one be enough?
It seems like that would be simpler, right?
Yeah.
But it's all about getting a more complete picture. Think of it like, imagine trying to understand a hurricane with just one weather buoy. You're only getting a tiny snapshot of what's actually happening.
Right. Makes sense.
But with two satellites, they can observe the polar cusp from different angles, giving scientists a much better understanding of the dynamics at play.
So it's like having two eyes to see in 3D.
Exactly. It gives them a three-dimensional view.
Okay, I'm starting to see why this mission is such a big deal. But who actually built these two satellites?
Oh, that's where Millennium Space Systems comes in. They're a Boeing subsidiary.
Oh, wow. Boeing.
Yeah, and they took care of everything, designing the satellites, putting them together, and guess what? They'll even be running the show from the ground, controlling those satellites from Earth.
Wow, that's a huge responsibility. So they've built these satellites. What kind of fancy tech are we talking about here? What's on board that lets them actually collect all this data about space weather?
All right, so each satellite is packed with these super sensitive instruments. They measure magnetic and electric fields, different types of plasma particles.
Plasma particles.
Yeah.
What exactly are those?
So you know about solids, liquids, and gases, right?
Yeah, basic states of matter.
Right. Well, plasma, it's often called the fourth state of matter.
Hmm.
It's kind of like gas, but the atoms are missing some of their electrons, so you end up with these charged particles zipping around. And guess what? The solar wind, it's mostly made of this plasma.
Okay, so plasma from the sun.
Yeah. And when it crashes into the Earth's magnetic field, it causes all kinds of crazy stuff to happen.
Like those geomagnetic storms, I bet.
You got it. So these instruments can also measure waves in the region too. Basically, they're taking the vital signs of that whole area where the solar wind is bumping into Earth's magnetic field.
Wow, that's amazing. But hold on a second. Why should we down here on Earth actually care about all of this? I mean, isn't space weather just a concern for, like, scientists and astronauts?
It's a great question. And, it might seem that way, but honestly, space weather can affect all of us.
Really?
Yeah, think about it. We rely so heavily on technology these days, right?
Oh, yeah, totally. Our phones, GPS.
Exactly. And all of that stuff can be affected by space weather. Satellites, communication networks, even power grids, all vulnerable to those solar storms.
Oh, wow. Okay, that makes it much more real. So how does Tracers actually help us predict these space weather events and, like, actually protect our technology?
Well, the mission is designed to give us a much clearer picture of what's happening in that polar cusp region.
Mm.
Remember, that's where all the action is, where the solar wind and the Earth's magnetic field are interacting.
Right.
So by collecting all this data on the magnetic fields, the plasma particles, the waves, scientists can improve their models and make those space weather forecasts much more accurate.
So it's not just about those pretty auroras, right?
No, not at all.
Mm.
We're talking about potentially avoiding disruptions to GPS systems, communication networks.
Even power grids, right?
Exactly.
Like a blackout because of a solar storm.
It could happen, yeah. And, disruptions to satellites, they can have a ripple effect. Think about financial transactions, emergency response systems, even national security.
Wow, this is serious stuff.
It is. And severe space weather events, they can damage power grids, causing blackouts that can last for days, even weeks.
Yikes. Okay, I'm starting to really see how important this mission is. So when are we going to see these satellites in action? When's the big launch day?
Well, they're planning to launch tracers in 2025 from Vandenberg Space Force Base in California.
Okay.
And get this, they're hitching a ride on a SpaceX Falcon 9 rocket.
Of course, it's a SpaceX Falcon 9. They're launching everything these days.
Seems like it, right?
It's like the workhorse of space travel. But how will these satellites orbit Earth once they're up there?
They're going to be in what's called a sun-synchronous orbit. That means they'll always pass over the same spot on Earth at the same local time every day.
Like clockwork.
Exactly.
Why is that so important?
Well, it keeps the lighting conditions consistent, for the observations.
Makes sense.
And it allows the satellites to focus on that specific region of the polar cusp where the action is, where that magnetic reconnection is most likely to happen.
So it's like they're constantly monitoring that one spot for any signs of trouble.
Exactly. And the data they collect will be incredibly valuable for scientists trying to figure out how all this space weather stuff works.
I bet. Wow, this mission is just blowing my mind. And we're only just scratching the surface here.
I know, right? There's so much more to explore.
I can't wait to dive even deeper. This Tracer's mission is really something else.
It really is.
All right, we'll be back in a bit to uncover even more about tracers and this fascinating world of space weather. Stay tuned.
Sounds good. And we've only just started to peek into the world of this mission. One of the most fascinating things about tracers is that it might actually help us understand this thing called magnetic reconnection.
Oh yeah, we briefly touched on magnetic reconnection before the break, didn't we? Sounds like something straight out of Star Trek. Can you remind me what it is again and why it's so important?
It's a pretty wild process, and it's actually involved in tons of astrophysical stuff, not just here on Earth. Basically what happens is magnetic field lines, like those coming from the sun and the Earth.
Yeah.
They come together, but instead of just merging nicely, they actually break apart and then reconnect in a totally different way.
So it's more like a forceful break and then a sudden snap back together.
Exactly. And when that happens, it releases this insane amount of energy. Kind of like if you stretch a rubber band really tight and then let it go, you get that sudden snap, right?
Yeah.
But in this case, we're not talking about a little rubber band. We're talking about massive magnetic fields.
Yeah.
So when they reconnect, it's like a giant explosion of energy. And this energy can actually make particles speed up to almost the speed of light.
Whoa, that's crazy. But how can tracers actually see this happening? It's not like they can just put a camera up there and film it, right?
Right, it's not quite that simple. But that's where those really advanced instruments on board come in. They can measure those really fast changes in the magnetic and electric fields that happen during these reconnection events.
Okay.
Plus, they can detect all those energized particles and waves that get created when that energy is released.
So it's kind of like they have a super high-speed camera capturing all the action and then a whole team of scientists back on Earth who can analyze that data and piece together what happened.
That's a great way to think about it. And by studying these events really closely, scientists are hoping to finally understand how they trigger those geomagnetic storms that can cause problems here on Earth.
So tracers might actually be the key to figuring out how to predict space weather accurately.
It's definitely a big step in the right direction. The more we learn about how space weather works, the better we'll be at knowing what's coming and getting ready for it.
And that brings us back to that sun-synchronous orbit, right? It seems like that's really important for tracers to do its job.
Oh, it's absolutely crucial. That consistent orbit, passing over the same spot at the same time every day, it helps for a couple of reasons. First, it makes sure the lighting conditions are the same each time they take measurements, so it's easier to compare the data.
Makes sense.
And second, it lets those satellites focus on that specific region of the polar cusp, where that magnetic reconnection happens most often.
So it's kind of like having a security camera pointed at that one spot all the time, just watching for anything suspicious. But instead of a camera, it's these high-tech satellites. And instead of a street corner, it's this wild region of space.
Exactly. And all the data they gather is going to be super valuable for scientists who are trying to unravel all the mysteries of space weather.
What are some of the things you're most excited about potentially learning from this mission? What kind of scientific breakthroughs do you think we could see?
Oh, there are so many possibilities. For one thing, we might finally be able to pinpoint exactly what causes different types of space weather events.
Yeah.
Like what sets off a solar flare versus a coronal mass ejection,
Right.
And we might discover all sorts of new patterns or connections that will help us predict how strong a geomagnetic storm will be and how long it'll last.
So it's not just about knowing whether a storm is coming, but also how bad it's going to be and for how long. That kind of information would be a game changer.
Exactly. Imagine being able to tell satellite operators, power grid companies, even space agencies, hey, there's a big geomagnetic storm heading our way, but it's only going to last for a few hours, so take these precautions. Or this one's going to be a doozy, so batten down the hatches, it's going to be rough for a couple of days.
It would be like having a weather forecast for space, but instead of rain or snow, we're talking about solar flares and geomagnetic storms.
That's a great analogy. And who knows what other amazing discoveries are waiting for us. Every time we send a mission like Tracers out there, we open up the possibility of learning something brand new about the universe and our place in it.
It's pretty mind-blowing to think about. It's like every mission pushes the boundaries of what we know, and Tracers is taking us another step closer to understanding how this vast, complex system of space works.
Yeah, it really is. And beyond those scientific discoveries, there's the potential for new technology to come out of this mission, too. When you have to design something to survive in the harsh environment of space, you often end up with innovations that can be used here on Earth as well.
So the benefits of tracers go way beyond just understanding space weather. It could lead to advancements in all sorts of other fields.
Exactly. The quest to explore and understand space, it often has these ripple effects that benefit humanity in ways we never expected.
It seems like we've covered a lot of ground today, from the nitty-gritty details of the tracers mission to the bigger picture of space weather research. But before we wrap things up, I have one final question for you.
I'm all ears. Shoot.
If we could perfectly predict space weather, what would that mean for the future of space exploration? What kind of things would become possible, and what new challenges would we need to overcome?
That's a great question to consider. If we were really good at predicting space weather, it would open up a whole new world of possibilities for space exploration. We could even start thinking about setting up permanent bases on the moon, or even Mars.
Wow, that's incredible. But we'd have to make sure those future lunar or Martian colonists are safe from those intense solar storms, right?
Oh, absolutely. We'd need to come up with some seriously advanced shielding technology. Maybe using some kind of new supermaterial, or even figuring out how to harness magnetic fields to deflect those harmful particles.
Like building a force field around the base.
Exactly. We might even need to rethink how we design habitats, creating structures that can withstand the most extreme space weather events.
So instead of just trying to adapt to space weather, we'd actually be creating our own protected zones out there. That's amazing. What about those massive solar power satellites, the ones that could beam energy back to Earth? Could we actually make those a reality if we were better at predicting space weather?
It's definitely possible. Imagine having these huge arrays of solar panels in space, constantly collecting energy from the sun. But yeah, to make that work, we need to make sure those satellites are protected from solar flares and those other intense bursts of energy from the sun.
So we'd need some kind of super durable material that could withstand those blasts of radiation, and maybe even systems that could anticipate those events and adjust the position of those solar panels to minimize any damage.
Exactly. It's a challenge, but it's also an incredibly exciting opportunity. It might sound like science fiction, but missions like Tracers are giving us the knowledge we need to make these kinds of technologies a reality. Every time we send a mission out there, we learn more about the forces that control our universe.
It's like Tracers is a stepping stone to a future where humanity can actually live and work in space, not just visit.
That's a great way to put it. By figuring out the mysteries of space weather, we're not just protecting ourselves down here on Earth, but we're also opening up a whole new frontier for humanity.
It's pretty inspiring to think about. Well, I think we've covered a lot of ground today. From the details of the Tracers mission to the future of space exploration, it's been an awesome deep dive into the world of space weather.
I agree. It's always exciting to talk about the missions that are pushing the boundaries of science and exploration.
And to our listeners, thanks for joining us on this journey. We hope you enjoyed learning about tracers and the fascinating world of space weather. Don't forget to keep looking up at the sky, because there's always more out there to discover.